MA Philosophy, MPYE-001, Logic. Block number 3, Unit number 1, Proving Validity Using Rules of Inference. Objectives. The principal objective of this unit is to illustrate the rules of inference with examples and to make explicit the art of testing arguments. Though these are dealt in the Unit 3 of previous block, here the focus is on formulating verbal form of arguments in their symbolic form and the prove the validity of argument. Such an exercise exposes the students to various rules of inference in proving validity of given arguments. Introduction. Logic is a science of right reasoning. All type of reasoning may not be valid, hence testing the rightness and wrongness of an argument becomes necessary. Logic classifies arguments as valid or invalid. We need a set of criteria for testing the validity of certain arguments. The symbolic logicians have spelled out certain rules of inference which would help us to see the correctness of certain arguments. In modern logic, an argument is regarded as a sequence of statements. When proof is constructed to test the argument, the proof also takes the same form which the argument takes. In this type of proof, there is correspondence between the scheme of the given argument and the scheme of the proof. Every step which is abu- which is adduced while constructing proof is the conclusion of the preceding statements and in turn becomes the premise of statements which follow it, if not all, at least to some rules which govern the process of deducing hidden conclusion constitute what are known as rules of inference in modern logic. Many of these rules have their origin in traditional logic. Necessity of rules of inference. As we have already seen that there are various types of syllogism, disjunctive, hypothetical, etc. The rules of inference have classified them into various form of criteria using symbols. However, only limited type of arguments are covered by classical logic. All types of arguments is not alike in all respects. These some are simple enough so that the truth table technique is adequate for the purpose of testing. Generally, any argument which consists of two or three simple but different positions can be easily put to test by truth table method. If the argument consists of more than three different propositions, then the truth table method is a bit difficult and confusing. In those cases, the symbolic logicians have proposed an alternative. Look at the following example and that make it point clear. An argument which is complex in sense is nothing but an aggregate of several simple. By simple in this context, we mean short argument. 1 p is equal to p is equal to q. So p you can see in a PDF IGNU e-content app. So below so q 2 q is equal to r, so q upon r. 10 p is equal to q is equal to r, so nothing. 3 is sum of 1 and 2 and in which the conclusion q and r is hidden. In classical logic, we have complex type of arguments in the form of stories. We should remember that complex, simple, etc. are relative. An example of stories is given. All Indians are Asians. All Dalits are Indians. All Mahars are Dalits. So all Mahars are Asians. In this polysyllogistic arrangement of argument, there are three premises and a conclusion. Usually, any stories consist of at least two syllogistic arguments and therefore two conclusions. So it is more complex than an ordinary syllogism. The point becomes clear when we break stories into constituent syllogism. all Indians are Asians. All Dalits are Asian. All Dalits are Indians. All Dalits are Asians. Conclusion: all Mahars are Dalits. All Mahars are Dalits. So all Mahars are Asians. Meaning of proof of validity: the rules of inference rules of inference in the sentential logic are based on the classical traditional logic. In symbolic or modern logic, an argument is regarded as a sequence of statements. While constructing the proof to test the argument, the proof has to take the same form of the argument to which it corresponds. So there is a correspondence between these two, the scheme of the argument and the proof to test it. Every step which is abduced while constructing proof is the conclusion of the preceding statements, and in turn becomes the premise for statements which follow it. If not all, at least to some rules which govern the process of deducing hidden conclusion constitute what are known as rules of inference in modern logic. A particular pattern of proof a particular pattern of proof construction is devised by modern logic, discarding more descriptive method which consumes both space and time. Modern logic has discovered much shorter and simpler method. Whatever conclusion can be drawn from any two given premises is written on head side LHS, while the rule and the premises to which this particular rule applies to derive the conclusion used in further proof are written on the right hand side RHS. The serial numbers are used instead of premises to make the procedure simpler and more economical in terms of time and effort to grasp the argument. Yet one must ensure that the premises, the conclusion drawn from them, and corresponding rules are always juxtaposed. For instance, let us look at the following argument: P is equal to small bracket Q V R small bracket close dash R dash Q, so dash P. There is a standard form in which we write the argument. After we write down the last premise, we use a slash on the RHS, which is followed by the conclusion. The given premises are numbered, and the subsequent conclusions which are drawn also are progressively numbered. We enter the numbers on the RHS accordingly. We shall rewrite the argument. Number one, P is equal to small bracket Q V R small bracket close. Second, dash R. Third, dash Q oblique so dash P. Number four, dash R A dash Q. 2 3 conjunction. Number five, so dash P. 1 4 empty. Empty stands for modus tollens, the rule which is familiar to those who have studied traditional logic. 1 and 4 signify first and fourth lines to which this rule is applied. We need not mention which is the premise and which is a conclusion before except the last line. All other lines consist of statements which are regarded as premises. It is not necessary that the premises should be written in the given order only. Care should be taken to omit conclusion from numbering. Finally, a word about symbols. We need not stick on to proposition form only. Hence when arguments are symbolized, we use only uppercase letters. Number 4, 9 rules of inference. This section may be a repetition of a unit in the previous block, which also lists out the same rules of inference. Modern logic consists 9 rules of inference. It is sufficient to know them and how and where they should be applied. There is no need to prove them. 1. Modus ponens MP. P is equal to Q. So conclusion Q. Second, modest tolerant MT. P is equal to Q dash Q, so dash P. 3. Hypothetical syllogism HS. P is equal to Q, Q is equal to R, so P is equal to R. Number 4. Disjunctive syllogism DS. PVQ dash P is equal to dash Q, or PVQ dash Q is equal to conclusion dash P. Number 5. Constructive dilemma CD. P is equal to Q A small bracket, R is equal to S small bracket, PVR, so QVR. Conclusion is QVR. 6. Destructive dilemma DD. P is equal to Q A, P is equal to Q small bracket A small bracket, R is equal to S dash Q B dash S. Conclusion dash P V dash R. 7. Simplifications P A Q, so P. 8. Conjunction P Q, so P A Q. 9. Addition A double D P, so PVQ. Absorption rule was added by copy to the remaining rules. In these rules, the first 6 rules are standard rules of traditional logic. The last 3 rules need a little explanation. In simplifications, since PAQ is given to us, we accept that P is true and Q is true as well. So there is no harm in dropping any of them. The case of conjunction is slightly different. P is given to us, so we take it as true. Q is given to us, so we take Q also as true. Since both are taken as true, we can conveniently conjoin them. The case of addition is slightly different. Suppose that we have only p in the premises. Since it is a premise, we take it as true. Suppose that we require q to be added to p. We do not know whether q is true or not. There is no harm in adding q to p, because even if q is false, q still remains true because p is true. After all, one true component can make disjunction true. But what is important is that conjunction does not mean addition. In logical language, addition means disjunction but not conjunction. Uses of rules of inference to test validity. 1. P is equal to small bracket P QVR. Second, dash R. 3 dash Q slash, so dash P. 4 dash R A dash Q. 2 3 conjunction. Number 5, conclusion dash P. 1 4 MP. Since this is the first argument, let us elaborate the process. Dash R appear in second line and dash Q appears in third line. Therefore, the rules of conjunction is applied. We get dash R A dash Q. This forms the fourth line in the sequence. Now we shall consider 1 and 4th line together. 1 P is equal to QVR. 4 dash R A dash Q. Conclusion dash P. In 1, QVR is the consequent, QVR being a disjunction. When it is denied in accordance with De Morgan's law, it becomes a conjunction with original disjuncts being replaced by their respective negation. Since consequent is denied in the second premise, the antecedent has to be denied in the conclusion, and it is done. Therefore, in traditional logic, it is a valid modus tollens, which has become a rule of inference in modern logic. For brevity, we say modus tollens. The form of 1 and 4 corresponds exactly to the form of rule 2. The conclusion which we obtained through formal proof is the same as the conclusion of the given argument. This is how an argument is tested for validity. This is a model of explanation which suits any argument. Converting verbal forms of argument into symbol. For change, let us start with verbal form of argument and symbolize the statements and logical constants before proceeding to test the validity of the arguments. Example 1. If Raja joins, then the club's social prestige will rise, and if Pandian joins, then the club's financial position will be more secure. Either Raja or Pandian joins if the club's social prestige rises, then Pandian will join, and if the club's financial position becomes more secure, then Suresh will join. Therefore, either Pandian or Suresh will join. Number one, Raja joins, or number second, the club's social prestige will rise. S. Number three, Pandian joins. K. Number four, the club's financial position rises. F. Number five, Suresh will join. G. Now the argument becomes one, r small bracket r is equal to s small bracket a, k is equal to f small bracket. Second, r v k. Third, small bracket s is equal to k small bracket a small bracket f is equal to g small bracket oblique conclusion conclusion k v g. Number 4, S SBF 1 2 CD. Number 5, conclusion KVG and 3 4 CD. Answer to the first argument makes 1 point clear. Verbal expression is naturally very long and tedious, whereas symbolic representation is short and clear. Example 2. Second, if Arivasan received the wire, then he if Arivasagan received the wire, then he took the plane, and if he looked the plane, then he will not be late for the meeting. If the telegram was incorrectly addressed, then Arivasagan will be late for the meeting. Either Arivasagan received the wire or the telegram was incorrectly addressed. Therefore, either Arivasagan took the plane or he will be late for the meeting. Number 1, Arivasagan received the wire V. Number 2, he took the plane P. Number 3, he will not be late of the meeting dash L is equal to dash L. Arivasagan received the wire is equal to V. He took the plane is equal to P. He will not be late for the meeting is equal to dash L. 4, telegram was incorrectly addressed is equal to dash T. Arivasagan will be late for the meeting is equal to L. Now the arguments becomes number 1, small bracket B is equal to P, small bracket A, small bracket P is equal to dash L. Second, small bracket dash T is equal to L small bracket. 3, V small v dash T slash conclusion PVL. 4, V is equal to P, 1 simplified, 6 P is equal to V, A small bracket A small bracket dash T is equal to L small bracket. 6 PVL. Rules of replacement. Now all arguments can be tested if restricted to rules of inference only. Though as shown above, somewhat complex and diverse arguments succumb to these rules, just as modern logic tries to supplement traditional logic. Within modern logic, the need was felt to supplement the rules of inference. Hence, we have the rules of replacement. The structure of argument may be such that it may require only one of the kind or both. We have 10 such rules, which are called the rules of replacement. The difference between these two set of rules is that the rules of inference are themselves inferences, whereas rules of replacement are not. This is because the rules of replacement are restricted to change or changes in the form of a statement. For example, if A or B is changed to B or A, then such change is governed by the rule. Similarly, if A small bracket BVC small bracket is changed to A AAB small bracket small b uh, small bracket AAC, then this change is governed by some other rule. Also, in the mode of application of rules, there is a restriction. Unlike rule of inference, which should be applied to the whole line, only any rule of replacement can be applied to any part of the line. This is because our rules of replacement are logically equivalent expressions. Now let us list rule of replacement. Number one, De Morgan's law, DAM dash small bracket PAQ small bracket is equal to triple is equal to small bracket PB dash PV dash Q uh, dash small bracket PVQ small bracket triple dash is dash P A dash Q. One commutation law, PVQ triple is equal to uh, QVP. PAQ triple is equal to QVP. Number three, double negation, dash small bracket dash P triple is equal to P. Number four, transposition, small bracket P is equal to Q small bracket triple is equal to small bracket dash Q is equal to dash P small bracket. Five, material implication, small bracket P is equal to Q triple small bracket uh, dash P V Q. Number six, material equivalence, P small bracket P triple is equal to Q small bracket triple is equal to small bracket P is equal to Q small bracket A small bracket Q is equal to P small bracket. Middle bracket A middle bracket small bracket P is equal to triple is equal to Q small bracket triple is equal to middle is equal to small bracket P A Q small bracket V small bracket dash P A dash Q small bracket middle bracket. Number seven, exportation, is middle bracket small bracket P A Q small bracket is equal to R middle bracket. Triple is equal to is middle bracket P is equal to small bracket Q is equal to R small bracket middle bracket. Number eight, tautology, P triple is equal to PVP P is equal to PAP. Nine, associations, middle bracket PV small bracket PVR small bracket middle bracket triple is equal to middle bracket small bracket PVQ small bracket VR middle bracket PA small bracket QAR small bracket middle bracket triple is equal to middle bracket PAQ small bracket R middle bracket. 10, distribution, is middle bracket P A small bracket QVR small bracket middle bracket triple is equal to middle bracket small bracket PAQ uh, small bracket V small bracket PAR small bracket middle bracket small middle bracket PV small bracket QAR small bracket middle bracket is equal to middle bracket PVQ small bracket A small bracket PVR small bracket middle bracket. Note, when the expression note both A and small v, only distribution law can be applied but not association law. Let us restate the De Morgan's law differently. Negation of a conjunction is equivalent to the disjunction of the negation of components, and negation of disjunction is equivalent to the conjunction of negation of component. Similarly, in the case of implication, the expression is equivalent to the transportation of the negation of components. Likewise, the rest of the rules can be treated. This relation becomes further clear if we construct truth table for any rule. For both sides of the equation, the student is advised to construct truth table for any rule of replacement to verify the equivalence. Our immediate task is to become familiar with the technique of testing arguments. These equation you can see in PDF in IGNOU content app. So I am not reading that. Let us sum up. Modern logic is an extension of traditional logic. However, there is a uh, uh, quali- qualitative difference in testing. Difference consists in accuracy and clarity of proof. 9 rules of inference include many rules from traditional logic like modus ponens. All 9 rules are not required always. Only some rules are required. There is no rule which says that one line must be considered only once. Thank you.